Practice exam number 3. So this is the non-multiple choice version of practice exam number 3. First question, find all the zeros of that function. How do we find all the zeros of a function? Well, let me move to the back where we have more room back here. And set up some paper. So number 1, the function is f of x equals six x to the third minus 5x squared minus 12x minus 4. Okay. Well, on the to find all the zeros, you need the first zero to be found from the graph. You got to have a zero to get you started. So you find the first zero from the graph, you graph it at desmos.com. So if you go to desmos.com and you type in this function, y equals 6x cubed minus 5x squared minus 12x minus 4 and graph it, you'll see on the graph right away that one of the zeros, it passes through a zero at x equals 2, meaning the function actually goes through the x-axis. It has a height of 0 at x equals 2. So that's a 0. That's what we mean by a 0, a place where the graph has a height of 0. So that's one of the places where the graph has a height of 0. So once you know one of the zeros, now how do you find the others? Second, do synthetic division by the first x equals 2, the first 0. So you put the 2 out here. Take these coefficients, 6 minus 5 minus 12 minus 4. And do synthetic division. So bring down the 6, and then 2 times 6 is 12. Add them up. 7. 2 times 7 is 14. Add them up. 2. And 2 times 2 is 4. Add them up. 0. That's the remainder. No big surprise. Remainder 0. That's because it goes in evenly. That's because x equals 2 is really a 0, which means it goes in with remainder 0. It hits the graph at a height of 0. Okay, so what are we left with? Well, if it originally started to the third power, then now it's been reduced by 1 because we've divided it. This is 6x squared plus 7x plus 2. So now we go on to step 3. And in step 3, I'll go to we're going to need to do the quadratic formula on that. So step 3. We have, what is it, 6x squared plus 7x plus 2. And we're going to use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is a, b, c, negative b, negative 7, plus or minus the square root of b squared minus 4 times a times c all over 2a. So there we go. Bring it down. We got negative 7 plus or minus the square root 7 squared is 49 minus 4 times 6 is 24 times 2 is 48. 2 times 6 is 12. We get to that. 49 minus 48 is 1. Square root of 1 is just 1. So that's negative 7 plus 1 over 12, or negative 7 minus 1 over 12. That's negative 6/12 or negative 8/12. Reduce both those fractions. Divide by 6 top and bottom here. It's negative 1/2. Divide by 4 top and bottom there. Whoop, negative 8 divided by 4 is 2. 2/3. So there's the other 2 zeros. So we found all 3 zeros now. So the first one was a 2 from the graph, and the other 2 were negative 1/2 and negative 2/3. There we go. Let's go on to number 2. It's kind of the same sort of thing. Question number 2 gives us the function f of x equals x to the third minus 3x squared minus 12x plus 10. And again, you would graph it. So the first step is to graph it at desmos.com, and you'll see right on the graph that one of the zeros is x equals 5, meaning over here at 5 the graph will go right through at a height of 0 over at x equals 5. And then the second step, now that we know one of the zeros, is we do our synthetic division with that first 0 we found. Putting in the coefficients of 1, negative 3, negative 12, and 10. Here we go. You bring down the 1, and we go 5 times 1 is 5. Add those up, 2. 5 times 2 is 10. Add those up, negative 2. 5 times negative 2 is negative 10. No big surprise. 0 remainder. So what does that leave us? This is 1x squared plus 2x minus 2. So that's what's left. That means when we took the original function and we divided by this 0, it left us with this. We're breaking down the original x to the third power polynomial. And so now we've got this x squared plus 2x minus 2 polynomial. In other words, really we're breaking down the x cubed minus 3x squared minus 12x plus 10. It's equal to x minus 5. Remember, whenever you're next to an x, you're always the opposite. So instead of plus 5, that's what the 0 is. It's plus 5. You make it x minus 5 times 1x squared plus 2x minus 2, meaning this. So we're breaking it down so far. And now we need to break the rest of this down. How do we break the rest of that down? Third step. We got to go to the quad. I don't know if I have room down here to do the quad. Maybe I do. Okay, so let's try the quad. Quad is negative b plus or minus square root of b squared minus 4ac all over 2a. So what are a, b, and c? So a is 1. B is 2, C is negative 2, so negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So we just got to simplify that a little bit. Let's see here, negative 2 plus or minus square root 2 squared. This is 4 plus negative times positive times negative. Watch your signs there. Negative, positive, negative. So 2 negatives is positive 8. Right? 4 times 1 is 4 times 2 is 8. It's positive because there's 2 negatives. Over 2. And so that's negative 2 plus or minus the root of 12 over 2. Now, what do we do with that? Well, do you remember that the square root of 12, let me bring it over here maybe. Square root of 12, if you break that down, it's 4 times 3, and that's 2 times 2 times 3. So that's the breakdown of the square root of 12. So this becomes negative 2. So let me keep going here. So this is 2 times 2 times 3. And remember how square roots work? 2 2's inside lead to 1 2 outside. So this becomes 2 root 3, doesn't it? So the square root of 12 is 2 2's in a 3, and 2 2's inside lead to 1 2 outside. It's the 2 for 1 deal. That's what square roots are. They're always a 2 for 1 deal. Now, how can we simplify this? Remember when these 3 outside the root numbers, if they're all divisible by the same number, then you need to do it. So divide by 2. Oops, that's a funny looking 2. Divide by 2, divide by 2, divide by 2. So when you divide them all by 2, you get 1, negative 1, careful there, right? Negative 2 divided by 2, and 1. So what is that? That is, I'm running out of room here, minus 1 plus or minus root 3. We don't need the 1 on the bottom. It's just 1. Dividing by 1 does nothing. Let me write this a little cleaner for you. So this, again, is negative 1 plus or minus root 3, right? Because this 2 canceled. This negative 2 here canceled, leaving a negative 1. This left a 1. I mean, you could put the 1 down here and the 1 right there, but they don't do anything. 1 times the square root of 3 is just square root of 3. And dividing by 1 doesn't change anything either, right? If you divide by 1, nothing changes. So we might as well just simplify by saying plus or minus root 3. Those are the other two zeros. So what are all the zeros? X equals 5, 1 plus root 3. Or sorry, whoop, that's a negative 1. The one after all that work mess up the answer. Negative 1, still scribbling here. Negative 1 plus root 3, and negative 1 minus root 3. So there we go. This was the 5, the original 0 that we would have found from the graph at desmos.com. So that's how that works. On the exam, on the actual exam, I'm not going to expect you to graph anything, so I'll just give you the first 0 right on the exam. And you can just find the other ones by synthetic division and then the quadratic formula. Let's try one more like this. So here's number 3. And it's f of x equals 4x cubed plus 28x squared plus 47x plus 35. And again, step 1, graph at desmos.com, an excellent site for graphing, and you'll find some zeros, and what you'll find is negative 5 and negative 1. Oh, I'm sorry. Negative 5. You'll find a 0 at negative 5. In other words, when you look at the graph back here at negative 5, the function will go through the graph. It'll be a height of 0 back at negative 5. So then step 2, you do synthetic. Synthetic division. So we'll put that -5, our first 0, out there, and then our coefficients 4, 28, 47, and 35. Here we go. Bring down the 4. -5 times 4 is -20. Add them up. 8. -5 times 8. -40, that's 7. -5 times 7 is -35, which makes 0 remainder. That's what we always get when something goes in evenly. So what that means is we just took this function and we just divided it by actually x plus 5. Remember, it's opposite sign when you're right next to x in a parenthesis. So we just divided by x plus 5, the 0 of -5, and we got the, so we know this is equal to x plus 5. This whole function here is broken down to x plus 5, and then this is going to be 4x squared plus 8x plus 7. It's got these right here. This is the x squared plus 8x plus 7. So we've broken down this original x to the third power function to be an x to the first power times an x squared. You know, if I actually FOILed that out, maybe it'd be worth showing you real quick, just so you really understand what's happening. I want to make sure you're really getting this. If I was to take this thing and go boom, 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 and then the 5 to all three, I'll go back to the original function. Let's see it. 4x cubed, right? This times this, plus 8x squared plus 7x. He's done. He's done. Now the 5 is going to go to all three, plus 20x squared plus 40x plus 35. I just kind of line things up. What do we got? This is 28x squared, 47x plus 30. See how that is the same as this? So my point is, we've taken the original function and we've broken it down a little bit, right? It was x to the third power, and we've factored out an x to the first power times an x squared. We don't need this. This is just proving that what we have is the same as what we originally had. It's just broken down a little bit. That's what we're trying to do here. We're trying to break down the original x to the third power. So now we can break this down further with the quad. So maybe I'm going to go to a fresh screen this time. So I'm going to take the, what is it, 4x squared plus 8x plus 7. And I'm going to do the quad on it. That's always your third. Oops. So always your third step is to do the quad (-b). Plus or minus the square root of b squared minus 4ac all over 2a. Unless you're a really good factor, you might be able, actually this one won't even factor, so just don't bother with it. Here's our a, our b, and our c. So (-b) plus or minus the square root of b squared minus 4 times a times c all over 2a. So where does that lead us? (-8) plus or minus 64 minus, let me see, I'm going to use my calculator, 4 times 4 times 7, 16 times 7. I'm getting 112 all over 8. Okay. Let's keep moving. So what do we got now? This is (-8) plus or minus the square root. 64 minus 112. I'm getting -48. Now, we got to simplify that. What do you do when you got a negative inside of a square root? Remember, that throws out an I. That's imaginary. You can't take the square root of a negative number. What times itself would ever be negative? Nothing. It's not real. It's imaginary. So whenever you have a negative in a root, you throw out an I for imaginary. Okay, so now I got to break down that square root of 48. Let me do it over here. That's 6 times 8, 2 times 3, 2 times 4, and 2. So if you break it down to all the little prime numbers that won't break down anymore, then you have square root of 48. What is it? It's going to be a 3 and then 4 2's, right? 1, 2, 3, 4 2's. Okay, now remember, square roots are a 2-for-1 deal. That's why we call them a square root, right? X squared. Square means 2. So square root, 2 root, it's 2-for-1 deal. So 2 2's inside, sends 1 2 to the front, and they're gone. 2 more 2's, sends another 2, and they multiply in the front just like they were multiplying on the inside. So 2 times 2 is 4, and the 3 is left inside. So bring that back. 4 root 3. So this is negative 8 plus or minus I times 4 root 3 over 8. Good so far. You see what's happening there? Now we need to simplify this. How do we simplify? Well, these 3 numbers, if those 3 numbers that are not in the root, those 3 outside the root numbers, if they're all divisible by the same thing, then you need to do it. And they are, huh? Divide by 4, divide by 4, divide by 4. They're all divisible by 4. So what does that leave us? Negative 2, right? This divides and leaves negative 2. This divides and is 1 plus or minus I root 3. We don't even need the 1. Doesn't do anything. And 8 divided by 4 is 2. So there it is. Now, how do you actually write that? Well, they want you to separate it. So you can say it's minus 2 plus I root 3 over 2, comma, minus 2 minus I root 3 over 2. That's a fine answer. But let me mention, on the multiple choice exam, they might do it differently. They might separate these guys separately over the 2. It's something you need to know. If you're going higher in math, going to calculus and things, is that they might separate these. So they could go negative 2 over 2 plus I root 3 over 2. Right, I just put this 2 underneath both of them separately. And so that's negative 1 plus I root 3 over 2. And then likewise, same thing on the other side, comma, negative 2 over 2 minus I root 3 over 2. These again cancel. Negative 1 minus I root 3 over 2. So this is a good answer, and this is a good answer. Both are good. They could do it either way. Either way on that. So the zeros then, all zeros would be the negative 5 that we got from the graph, the Desmos graph, and then these other 2, or you can list them this way. They're the same thing, said either way. Neither one's more simple than the other. Both are good. I'm just going to go negative 1 plus I root 3 over 2 and negative 1 minus I root 3 over 2. There's the 3 zeros. Which means in reality, only one of those is a real 0, isn't it? This is a real number, but this right here is an imaginary number. It has an I part to it. You might say, well, yeah, but the minus 1 is real. Yeah, but it's altogether, this is a complex number. It has a real part and an imaginary part, so overall it's not real. And this thing here is imaginary also, isn't it? Right? If I say I have 7 plus 3 imaginary dollars, that's not 10 imaginary dollars. That's not any real amount of dollars. It's imaginary. So the point is the only real 0 is the negative 5. That means that's the only place where this graph actually hits the x-axis in reality. The other zeros are make-believe. They're imaginary. In other words, there are no other real zeros. There's no other real place the graph hits the x-axis. Only at negative 5. That's the only real 0. Okay, so number 4. Number 4 gives us a function, 3x squared plus 4x plus 1 over 2x squared plus 15x plus 25 and step 1, first question is they want the Y-intercept. So if you're moving on into calculus and stuff, you got to get more and more comfortable. What's a Y-intercept? That always means set x to 0, doesn't it? This is y out here. Function values are y values. And whenever they ask for a y-intercept, that means make x 0. And if they ask for an x-intercept, which they will in a second, that means make y 0. So intercepts always mean make the opposite letter 0. Why? Because that's what it means on a graph. Look at this graph for a second. This is a y-intercept, hits the y-axis. This is an x-intercept. Think about the coordinates of that x-intercept. It's over some number, I have no idea, but up 0. See how the y-coordinate is 0 at an x-intercept? And at a y-intercept, this is over some, oh no, this is over 0, up some number, I don't know. See how his x value is 0 at a y-intercept? So that's just the very meaning of what it means to be a y-intercept. Your x-coordinate is 0, you're over nowhere. And if you're an x-intercept, you're hitting the x-axis, that means your height is 0, your y-coordinate is 0. So the opposite letter is always 0. X-intercept has y 0. Okay, so let's do it then. How do we find the y-intercept? We said x equal to 0. So let's take this function and make x 0. So I'm going to plug in 0 for x here, right? 0 here, 0 here, 0 here, 0 here. In fact, how about I just cut through it and say, look, it's just going to be 1 over 25. Everything else cuts out. So then the point is 0, 1/25, right? We put in an x value 0 and we got a y value 1/25. That must mean that's the y-intercept. That's where the graph hits the y-axis. Step number 2. Find the x-intercepts. A little more tricky here. So to find x-intercepts, you're going to set y to 0. Okay, where's y? Well, y is over here on the left side. So I'm going to make the left side 0. Like this. Okay, and so now how do I make a whole fraction equal to 0? This is a very important question which needs to become really clear in your mind if you're going on up, as I keep saying, I'm getting you ready for calculus here. The only way a fraction can equal 0 is if the top is 0, right? Because this is 0 over 1. The only way a fraction can be 0 is if the top is 0. It means nothing about the bottom. It means the top must be 0. That's the only way a fraction can be 0. Because 0 over anything, like 0 over 7, is 0. If I say I ate 0/7 of the pie last night, that's just a weird way to say you ate 0. No pie, right? 0 pie. Now you might think, well, what about if 0's on the bottom? Remember, that's infinity. That's not 0, that's infinity. Because 0 goes into 3 an infinite amount of times. So that's different. All right, so whenever a fraction is equal to 0, that means the top is 0. That's the only way that a whole fraction can equal 0, is if the top is 0. So that means the top, 3x squared plus 4x plus 1, must equal 0. So we set y equal to 0. Y is the whole function, which means the whole fraction equals 0, and the only way a whole fraction can equal 0 is if the top is 0. So I got to solve that equation equal to 0, that top equal to 0. How am I gonna do it? Well, quadratic formula, right? This is A, B, and C. Yeah, or you could factor. If you're a good factorer, that would probably save you some time. I'll do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's negative 3. Nope, whoop, I did the wrong thing there. Negative b, negative 4 plus or minus the square root of b squared minus 4. times a times c all over 2a. And so that's going to be negative 4 plus or minus. That inside becomes what? 16 minus 12 all over 6. Negative 4 plus or minus the square root of 4 over 6, which is negative 4 plus or minus square root of 2. I mean, square root of 4 is 2. And so that's negative 4 plus 2 over 6. I'll bring it up here. And negative 4 minus 2 over 6. So that's negative 4 plus 2. What's that? Negative 2 over 6. And negative 4 minus 2 is negative 6 over 6. So this is negative 1/3 and negative 1, right, when you reduce those fractions. So there's the two answers. Or, you know what, we could have just factored this thing and it would have saved us a little bit of time. If you're a good factor, you want to increasingly be comfortable with factoring if you're moving on up to calculus and stuff. You want to be able to factor. So this would have factored 3x and x, that makes 3x squared, and 1 multiplies to be 1. And then you can check it. You know, if you multiply this out, you get 3x squared plus 3x, boom, boom, plus 1x plus 1. See how that's 4x in the middle? That matches. And then you just set each of these equal to 0. So 3, right? Because if two things are multiplying to equal 0, either one could be 0. Either one could be 0. I hope I'm not confusing you right now. I'm showing you a second way. We're done with this part. These are the answers, but I want to show you what would have been a quicker way. If you practice factoring, you'll get quicker. So you factor, and then if I said, hey, I'm thinking of two numbers and I'm timesing them in my head, and it's coming out equal to 0. How can you multiply two things? See how these are multiplied? Something multiplied by something, and it equals 0. The only way you can do that is if the first one is 0, or the second one is 0, right? That's how two things can multiply to be 0. The first one, this one could be 0, or the second one could be 0. Either way, if either one of those is 0, they'll multiply to equal 0, won't they? So then solve this one, jump the 1 to the other side, negative 1, divide by 3. See, there's that first answer we got, negative 1/3. Jump the 1 to the other side. You know, things switch signs when they switch sides. So there's the same two answers by factoring a little bit quicker. Now, we have to give, I'm kind of out of room here. Let me do it right over here. We have to give these answers as points, though, not just x values. So they want us to say minus 1/3 0, comma, minus 1 0, because that's the x value going with a y 0 and the other x value going with a y 0. They both came from making y 0. Okay, and that's just the first two parts. We got more work to do here. Now, back to the function again. Y equals 3x squared plus 4x plus 1 over 2x squared plus 15x plus 25. They're going to ask us on part 3 now about the vertical asymptotes. So what are the vertical asymptotes? How do you find vertical asymptotes? Well, vertical asymptotes are when the denominator equals 0. Because if you have anything over 0, remember that goes in there an infinite amount of times. If the bottom goes to 0, the fraction goes to infinity. And that's what a vertical asymptote is, right? It's a place on the graph where it goes up or down to positive or negative infinity. So what makes a fraction go to positive or negative infinity? When the denominator is 0. So they want me to take this denominator right here, 2x squared plus 15x plus 25 equals 0, and solve that. Now, again, I'm going to factor here. You could do the quad. You know, again, I'm going to say either way. Could use the quad. You know, the negative b plus or minus the square root of b squared minus 4ac all over 2. You could do that. You can solve any x squared equation that way. But it's better if you learn to factor. You're going to need to learn to factor if you want to go into calculus. You'll never make it in calculus without factoring. So 2x times 2x is 2x squared. And now I need what multiplies to be 25? Well, 5 times 5. But is that right? Both plus? Let's check it. That's the thing. You got to get good at checking your factoring. If I was to take this 2x squared, this 2x to both would be 2x squared plus 10x, and then the 5 to both plus 5x plus 25. Sorry, I'm getting a little scribbly, going fast. See how these middle two make 15? It's right. Go check. It's the correct factoring. And then what do you do from there? Remember, you set each one to 0, because if two things multiply to equal 0, either one could be 0 to make that happen. Then jump the 5 over, divide by the 2, and jump the 5 over. Okay, so there's the two vertical asymptotes. -5 and -5 halves. That's places where the graph is going to have vertical asymptotes. Finally, they want us to find the horizontal. Y equals, again, 3x squared plus 4x plus 1 over 2x squared plus 15x plus 25. And they want the horizontal asymptotes. Well, how do you find horizontal asymptotes? Well, remember, a horizontal asymptote is some kind of height the graph approaches as x goes to infinity, as you go way, way off to the right. So I always say, just plug in x equals 100. Just go way over here to 100 and find out if the graph is leveling off at a certain height or not. What are you going to get? 3 times 100 squared plus 4 times 100 plus 1 over 2 times 100 squared plus 15 times 100 plus 25. Now, can you see what's going to happen? 100 squared means 100 times 100. So it's 100 and then add 2 more zeros, because when you multiply by 100, that adds 2 more zeros. So that's what? 10,000. 100 squared. Same thing down here. 100 squared is 100 times 100, which means add 2 zeros to 100. That's what happens when you multiply by 100. So that's 10,000. So this is 3 times 10,000. Plus, and then 401. And down here, 2 times 10,000 plus 1,500 plus 25. Do you see that this guy and this guy are so much bigger than these little silly numbers that those other ones don't even matter? Right? And we're only at 100. If I went all the way to 1,000 or 1,000,000 or 1,000,000,000 or 1,000,000,000,000, more and more, all that would matter would be this term and this term, because they're the most powerful term on the top and the bottom. They're all that's going to matter. Right? 30,000 is so much bigger than 400. It doesn't even matter, basically. And I'm only, like I said, at 100. If you plugged in 1,000, 1,000,000, 1,000,000,000, those other ones are so small. So really, what's going to happen is you go way off to the right. Way off to the right at 1,000, 1,000,000, 1,000,000,000 is the most powerful term on the top, and the most powerful term on the bottom will take over. And all the other stuff will be so small it won't even matter. It'll be just a blip on the screen as you go way off to the right. So that's how you do horizontal asymptote. What's going to happen then? How do you simplify that? These cancel. So y will come to 3 halves, which is the same as 1.5. That means this graph is going to get really, really close to a height of 1.5 as you go way off to the right, because the most powerful term on the top and on the bottom will dominate, and all the other stuff will be small potatoes. And that's the horizontal asymptote. They want a fraction, so they want you to say it that way. Y is 3 halves.